Hello boys and girls, and welcome to lesson 5-2 of your study guide, Unit Rates. This lesson is found on page 99. As you probably already know, we're going to find unit rates and compare unit rates. On the side we have the quick review. Let's go ahead and do it as a key answer. There are 15 girls to 13 boys in class. Write the ratio of boys to girls. Okay? That's what we're going to do. We're going to write the ratio. So we have 13 boys to 15 girls. Okay? Or we could write it as 13 to 15. Or we can even just write it 13 to 15. Okay? Please write all three of these forms as a key answer. A rate is a ratio of two measurements having different units. Okay, so it's not a fraction, it's two different measurements or two different numbers with different units. Okay, we can have centimeters to meters, or even from customary to metric system, we could have 12 inches to, I don't know, 35 centimeters. When a rate is simplified so that it has a denominator of 1, it is called a unit rate. So we could say, for example, for every 12 inches, we're going to have 1 foot. That would be within the same system, right? So every 12 inches is 1 foot. Because we have the 1 down here, this is considered a unit rate. Okay, every foot is 12 inches, or every 12 inches is 1 foot. Complete the Venn diagram. This is a Venn diagram. I'm sure you've seen it many, many times. By writing the phrase below in the correct position. So we're going to try to identify what is a rate and what is a unit rate, and then see what goes in the middle for both of them. So let's say $24 for 3 pounds. Okay, $24 for 3 pounds. If it were $24 for 1 pound, that would be a unit rate, and it would go right over here, but it doesn't. It's just a simple rate of $23. It could be $8 for 1 pound, right? Because you divide them both by 3, then it would go here. But it's just simply a rate that will go here. Now we have $10 per hour. Per hour means $10, something that looks like this, 10 to 1. So we have our unit right there, 1 hour. Okay, $10, which is the unit here is money, and here it's time, it's hour, 10 to 1. Continuing on this side, we have 18 red cars to 6 blue cars. 18 to 6. If I were to simplify this, I could have 1 to 3, right? That would be my unit rate, and I could write it here, but it's not written as a unit right now, it's simply written just as a rate. So we write it here. 15 students per teacher. So every teacher has 15 students. That's a unit rate. And finally, can be written as a fraction? Well, can you write this as a fraction? Yes, of course you can. And this one? What about this one and this one? They can all be written as a fraction where we compare two numbers. So it can be written as a fraction, can be written right in the middle. Okay, please copy all this down. Let's make this a key answer by putting a star in each corner. There we go. Now let's look at the real world link, the real world connection. Texting. This is something all of you know about. When sending a text message to a friend, Markeisha typed 90 characters, 90 letters, in a little more than 60 seconds. If she typed at a constant rate, how many characters did she type each second? So each second, she's typing more than 1, right? Well, I can see that if she were to write 60 characters, right? If she were to write 60 characters in 60 seconds, it would be even. It would be 1 per second, correct? But no, she's doing instead 90 characters in 60 seconds, right? If I were to simplify this to a unit rate, okay, I would want to find how many of these are in here, how many seconds, right? What I could do is I can figure out how many characters do I do per second, to the point that I bring it right down. Let me move this a little bit out of the way. Okay, where I would bring this right down to 1. So there's, how many 60s are here? There's 1 60 there. But how many 60s do I have in 90? I know I have at least 1, and then I have 30 left over, right? I have 30 left over. 30 is half of 60. So we could say 1.5. 1.5. Therefore, Marquisha can type about 1.5 characters every second, per second. You see it right there? Every second she can do about 1.5. To the point that when she's done 60 seconds, she gets all the way to 90 characters. Okay, now on the next page, we have to determine if each situation in the table represents a unit rate. Write Y for yes or N for no. If no, rewrite the situation as a unit rate. Okay, 60 pages read in 40 minutes. Clearly, it's 40 minutes. It's not 1 minute. So this is not a unit rate, or it's not even 1 hour as well, right? So we have to bring this down to 1 minute. If we bring this down to 1 minute, how many pages can be read? Well, it's the same situation that we just had previously. We have 40 here, so in 40 minutes, 60 can be read. So we know how many 40s are here? Sorry, how many 40s are here? 1. And here, we have at least 1, and then another 20. And we know 20 is half of 40, so we have 1.5. Okay, if we were to simplify. Clearly, this is not a unit rate, so we put N. But we can simplify it and say that 1.5 pages per minute. Let me write that nicer. Okay, there it is. 50 miles per gallon. 50 miles per gallon. Gallon of gasoline, of course, and it's per 1 gallon. So yes, this is a unit rate. Yes. $7 per ticket. Good. So 1 ticket is $7. Yes, this is again a unit rate. Let's see here. 300 miles driven in 5 hours. We need to bring this down to 1 hour. So let's see if this divides by 5, and it does. 30 divides by 5 in 60, right? 5 times 60. So this would be 60 miles in 1 hour. Right? $9 for 2 sandwiches. What about for 1 sandwich? Well, we divide this by 2 to see how much 1 would be. But so clearly this is a no. And I know that it's going to be, when I divide 9 by 2, it's going to be $4.50, right? Per sandwich. Or you could write each as well. And finally, 5 pencils for each student. 1 student gets 5 pencils. So yes, this is definitely a unit rate. It's down to the simplest form. Each, you see each, or per ticket, or per gallon. Whenever it's down to 1, it's a unit rate. So yes, it's a unit rate. Okay, go ahead, copy these things down. And finally, we're going to compare. Fill in the blank with less than, greater than, or equal to compare the unit rates. Then explain why you chose the sign that you did. Okay, so we have 10 books for $12. How much is each book? I can write it into a fraction, and I'm going to divide the number of dollars by the number of books so I can figure out how much is 1 book. This is what I want to bring down to the unit rate. How much is 1 book? So I have my $12 divided by 10, and that's just going to move my decimal place over by 1, as you already know. So that means it's $1 and $1.20 per book, right? And then over here, I have 15 books for $18.75. Same thing. We have, I guess I'll just do this. 15 books divided by 18 and 3/4, right? But I'll just write it as 18.75. Oh, I did that backwards. Okay, I hope you caught my mistake. And then remember, we always learn from mistakes. So what I did originally was I put the books on the top. I want to put the books on the bottom because that's the one I want to know the unit rate of. I want to know what 1 is. So I put the money on the top, the book on the bottom. And when I divide 18.75 by 15, again, I get a decimal of 125 per book. So which one is greater, less than? Clearly this is bigger, right? So there's our answer. So 10 books for $12 is less than 15 books for $18.75. So this is the cheaper option. And make sure you copy all this down as you see it so that I know that you've watched the video. Let's do the next one. 12 cans for $4.20. Again, I want to see how much 1 can is, so my 12 is going to go below. Alright, and my $4.20 will go above. And when I do that division, I get 35 cents. 0.35 per 1. Right? And then for the other one I have 20 cans. Again, I want to know how much one can is, so I'll put the can on the bottom, and then I bring it down to 1, and when I divide 6 divided by 20, I get 0.3. Wow. But because it's money, I add the 100th place. So it's 30 cents for one can. Alright, so here I have 30 cents. Well, here I have 35 cents. So which one is less? Right? That one's cheaper. So let's write our therefore statement. 12 cans for $4.20 is greater than 20 cans for $6. So this is your better deal. And boys and girls, this is real world math. Whenever we go to the market, it's always good to see these prices because it's often cheaper to buy in bulk, to buy more. It gets cheaper by the unit rate. Not so much for these books though, right? Okay. Please write 2 to 3 sentences about what you learned today. I know that you learned about unit rates and you learned to compare unit rates, but you can go ahead and add anything else that you felt you learned. See you in class, everyone.